Hey, Greyfriars community, welcome to the wintertime themed part of our science class. In the next 2 weeks, we're going to use some science to have some winter type fun. First, we got to start out with a review, huh, Holly?
Yep.
Are you ready to help me? Okay,
yeah.
Do you remember, what are two types of bonds? Do you guys remember?
I remember types of bonds. Ionic and covalent.
Very good.
Covalent.
So you guys, we have two types of bonds that we've learned so far, ionic and covalent. Remember that ionic, think of to nick is like to steal something. So think of, remember how we talked about how every atom has protons, neutrons, and electrons. The protons and neutrons are in the middle of the atom, in the nucleus. And the electrons float on shells. And each shell has a certain number of electrons that it can hold. And they always count outward. 2 on the first one, 8 on the second one. I can't remember every shell. But based on the number of electrons, every element has its own number of electrons that it has. It defines that element, right? Depending on how many protons, neutrons, and electrons, that's what defines an atom as a certain type of element, okay? So if it has, like oxygen, has 8 electrons, that means it has 2 electrons on its first shell and 6 on its second shell. The second shell wants to have a full 8. Remember our rule of 8? The outer shell always wants to have 8. So it has, what's 8 minus 6? 2, right? So it can have up to 2 more electrons, which is where it's open for having a bond, right? Like hydrogen has 1 atom. So if we have 1 electron, so if we have 2 hydrogen atoms, it will bond with the oxygen because the electrons will join together to make 8 electrons on the outer shell of the oxygen, okay? So ionic is when, rather than sharing the electrons, one of them steals the electron from the other, and it leaves a charge. So one of them has more electrons than it should, and one has less electrons. So they're charged atoms then. Covalent, think of all the ships sitting in a cove together. They're sharing the space. So covalent bond, like H2O, is when the electrons are shared. Today we're going to learn about 2 types of covalent bonds, nonpolar and polar. I'm going to show you a picture to make this easier to understand. These are a lot of big words. Do you remember, why are we studying this in 3rd grade, 4th grade, 5th grade? Do you need to know all this stuff yet? No, but you guys are so good at learning. Why not learn it now? That way when you get to high school and you're having to learn really fast and not only learn the material but also use it and argue with it and engage with it in a really productive way, you already have all this stuff memorized. You're not having to learn the vocabulary in high school. You've already got it in here. So don't worry if you don't understand all of this today. But at least get the concept so that in middle school, it will be easier when you do chemistry. High school, college, your chemistry classes will be easier if you already have the vocab up here. So a nonpolar covalent bond, so a nonpolar molecule, the electrons are shared equally. See, we have 2F. These are iron atoms. And notice this one has 7 on its outer shell. This one has 7 on its outer shell. And so they're sharing to get the full 8 on each of them, they're sharing like this. They're pulling equally on each other because this one gives 1 to this one gives 1 to this one. And so there's an equal tug. Polar. And I always remember, I first learned the word polar, not like polar bears, but like a polarized thing. I remember Polaroids, polar batteries, in terms of batteries. With a polar bond, covalent bond, electrons are shared unequally, meaning that one of the atoms tugs more than the others. So like hydrochloride, which is used to make muriatic acid. Remember, like we talked about how we cleaned our garage floor with muriatic acid. So hydrochloride, the chlorine has 7 on its outer shell. hydrogen has 1. And so when they bond, the chlorine has a greater pull than the hydrogen does. So it's polarized. It kind of causes a charge in the same way that the ionic causes a charge, but these are bonded differently than an ionic. Okay, how about H2O? It's a polar covalent bond because the oxygen tugs more than the hydrogen. See, each of these hydrogens gives 1 electron and the oxygen has 6. So the oxygen pulls more. Make sense? Why does this matter, you guys? So here's everything you've learned so far. We've learned about matter. Everything's made up of matter. Depending on the type of matter, the type of atoms, we have elements that combine elements, like we saw in the periodic table of elements. I don't know where I put my periodic table of elements, but it is great fun. I hope some of you are working on your candy bar challenge of memorizing the elements song. That's a separate challenge from your normal memory work. No problem if you don't do it. It's just an option. Okay. Then an element on the periodic table is either divided as a metal or a non-metal. And we remember how we had the division of the periodic table into rows and columns and rows. And then we had the noble gases on one side. When we combine elements, that's when we get compounds. And these compounds can either be ionic, like we said, when the electron is stolen, or covalent, which is molecular. And then the molecular compounds can be polar or nonpolar. We've also learned, before we get into our craft, we've learned 2 types of mixtures. Do you remember our types of mixtures, Holly?
Types of mixtures.
Homogeneous, same throughout. Heterogeneous, different throughout. Are 2 types of mixtures. Homogeneous, heterogeneous. Very good. Okay, so homogeneous. Do you remember when we did our project where we had sand and water, we had sugar and water, salt and water, we had oil and water, salt and pepper, trail mix, various mixtures of things. If it's homogeneous, Holly, will you step over to the side so you can see the sheet too? Homogeneous means that if I take a sample, no matter what sample I take, it's going to be the same. So like the table salt and water, NaCl and H2O, when we mix them, the salt dissolved. That's a homogeneous mixture. It's equally salty throughout. That's called a saline solution. A solution is another word for a homogeneous mixture. Remember, one thing to know is if you ever hear the word homogenized, that's the process of making milk the same throughout. Homogeneity is the noun version of this. There are lots of words that if you know this word, it opens up your understanding of lots of other words that you might come across in life. Heterogeneous, on the other hand, was when it was different, right? Like trail mix. If I get a scoop of trail mix, it's not going to be the same. I know some of you guys are the types to pick out all the M&Ms, right? So that's a heterogeneous mixture because you can take out individual pieces and not have the same. Oil and water was a heterogeneous mixture because the oil doesn't dissolve. So that brings us to our memory work for today. 8 minutes in, my goodness. What is the chemistry rule for dissolving? Like dissolves like. So why did salt dissolve in water and oil doesn't? It comes down to that polar versus nonpolar and ionic. Depending on what type of compound you're dealing with, they dissolve differently. So NaCl and H2O. NaCl is an ionic. Let me double check, make sure that I'm not misrepresenting this. Okay, I'm going to check my paperwork. So NaCl, let me see, is an ionic compound. Water, so it has a charge, an electron charge, right? H2O is a polar covalent bond. So even though they're different types of bonds, they both have a charge. They're similar. So as a result, they dissolve together. Oil is a really complicated combination of compounds, okay? But it is a non-polar covalent bond, and water is a polar covalent bond. They're not similar. This does not have a charge. This does. Moms, you pay attention during this part of the video. This is super important to understand if you ever have to do laundry. Do you think any of you will ever have to do laundry? I hope you're all raising your hand. Someday you're going to have to do laundry. Let's say boys, you go out and you're roughhousing outside, maybe playing soccer, football, tackling each other, and you get a grass stain on your pants. Or even worse, maybe you land on a stick and you get a cut and then you get blood on your clothes. Can you wash it out with just water?
Yes.
Yeah, it's good to run water on it and scrub it, but the blood won't come out. Why? Because your grass and your blood are both non-polar compounds, okay? Water is a polar compound. They don't like each other. What do we need to use to wash our clothes? Soap. Soap, right? So soap is interesting because the molecular structure of soap, it's so amazing that someone came up with this. Like someone knew what combined with what. It might have been an accident that they discovered it, but it's amazing that through science, we can understand what's actually going on when we wash our clothes. So soap on one side is an ionic bond of the compound. On the other side is a non-polar compound. Guess what? Like stuff likes each other. So the ionic side bonds with the water, which is a polar bond. Not polar bear. Remember, not polar bear, polar bond. Okay?
Polar bears are
Hold on. No, we're focusing on this. The other side of your soap molecule is a non-polar compound, or non-polar compound. So then it bonds with the grass stain, or the blood stain, or the oil stain. Soap by itself will not get it out. Water by itself will not get it out. But water with soap gets out your stains. Isn't that amazing, you guys? So then that's why if you go to the fabric store, you can find individual stain remover for every type of stain. Based on the chemical structure, there are certain things that will get a stain out better than others. And it's chemistry in action, you guys. So cool. So let's get to the fun part. We're going to need some supplies. If you're doing this at home, you'll need some pipe cleaners. You can look online. I will possibly try to post to see if there are any alternatives that we can use. I need you to not interrupt me, Holly. You basically need something that can form a six-sided structure, okay? We're going to cut one pipe cleaner into 3 pieces and overlap them in the middle. I'm going to then fold 2 of the pieces over. So your total of 4 sides will be moving places. Hold on, Holly. Let Mama teach, okay? So you're going to end up with a 6-sided thing like this. Holly, do you want to grab one to do over here? Can you do you want the pink one, the blue one, or the white one?
I want to make a white one.
Okay.
And then with the other one so I can make more.
Yeah, that's fine. So you're going to put them like this.
Where are my other pipes?
I'll show you after we finish filming. And then, okay. So we're going to just fold over the sides. And then we'll need to trim these. You'll need a mason jar. You'll need some yarn or thread. These are easy enough to cut. You do not need wire cutters for them. You generally cut them with just plain scissors. What I like to do then is once you have your 6-sided shape, is take a piece of thread. I think I knocked my thread on my seat. There it is. And I prefer to just tie it. You want to tie it just I took maybe a 10-inch piece of thread. I'm going to tie it so that it's maybe 2 inches on each side. Okay, you want to have a circle that's about 4 inches around, maybe a little bit less. And then I'm going to fold over the side of one of our edges of this. I'm going to fold it over on here and make a little loop for this to go through. Okay, you guys, it doesn't have to be perfect. You can do it however you want. I'm going to then trim all all of the edges to be about the same size. Okay, easy peasy. We're gonna then grab, I'll need you to have some borax soap. You'll need 3 tablespoons for 1 jar, for 1 snowflake, and you'll need a cup of water, okay? So here's my snowflake. I'm gonna use, you can use either, I have coffee stirrers. You can also use a popsicle stick or a pencil, anything you want. And what we're gonna end up doing
And putting it
is lowering it into a mason jar, okay?
It'll look like this.
So it'll end up looking like that. So I've made a few ahead of time. You can also grab food dye if you would like. I'm gonna go grab our boiling water and we're gonna start mixing up our solution of borax and water. Okay, so we have some boiling water and we have some borax. Borax is just a laundry detergent. Do not buy Boraxo soap. It's a totally different thing. The 20 ml borax. Most of the grocery stores are sold out right now. Lowe's had it. But maybe ask your mom and see if she has some in her laundry room. Do not use this without adult supervision, and definitely do not lick your fingers without washing them when you're doing this craft. So even household items can be dangerous, right? Like we talked about, combining certain things in a certain way can be dangerous. What I'm going to do is I'm going to add hot water to the jar. This is boiling water and your glass will get hot. So please be super careful, you guys. I'm going to fill it about halfway, and then might fill it a little bit more just to make sure that my thing fully submerges. So this is a 2-cup jar, so I'm going to fill it with about 1 cup of boiling water. Again, your jar is going to be super hot. You can wear gloves. I'm also going to use a piece of masking tape for our classroom version. Just writing your name and your grade on it, okay, is what we're going to do this week. With masking tape. There you go. You can also do it with a Post-it note. Or we can also label your straws. So we'll see what we decide to do in class. Now, we are going to take some borax soap. I have it pre-measured for the classes. And we're going to use about 3 spoonfuls of it. 3 tablespoons, okay? So 1, and then I'm going to mix that in. This is where it might be nice to have skewers or I mean, the coffee stirrer obviously can handle the heat, but you might want to have a wooden craft stick or something for stirring, or a skewer, or a pencil that can go all the way into it. Okay, I'm gonna add 2, and then I'm gonna add 3. What's happening here chemically is that the borax, when we boil water, okay, the water molecules spread out as they boil, okay, and it makes more room for our borax to dissolve. We're making a water and borax solution. It will be, as the borax is fully dissolved, it's going to be the same throughout. So it's a homogeneous mixture, which is also called a solution, okay. There's like properties, right? So the borax wants to dissolve in the water. When we reach a certain point, called the point of saturation, when we can't add any more borax and have it dissolve, there's a point where the water just can't hold any more borax. That's the point of saturation. So we're going to use about 3 tablespoons per cup of boiling water. Yours might be able to hold a little bit more or less. So just keep going until the borax stops dissolving. Okay. There we go. And sometimes you'll get clumps in your borax. You'll want to break those up before you add it because it's kind of hard to stir them in. Okay. Okay, once we have it fully dissolved, you're going to use your coffee stirrer and put it through the hole of your string and lower your star into the borax solution, okay? Just like that. I'll hold it so you can see into here. Let me see if I can line that up. So the pipe cleaner is fully submerged. You guys, as the water cools, the molecules get closer again, okay, which leaves less room for the borax to be dissolved. The water won't be able to hold as much borax, and so the borax will start to crystallize. Any of you who did geology last year with us will remember that there are certain ways that certain things crystallize. Salt forms square crystals. Water forms six-sided crystals. That's what snowflakes are. The borax will form, sorry, my phone cut out, will form crystals on our pipe cleaner and form a beautiful snowflakes. This is a great project that you can use as a decoration if you have a Christmas tree or around your house. You could decorate Christmas presents with it, or, you know, give these to friends as them on their own because they're beautiful. Or Holly also had the idea of selling them. We'll see.
Well, I had the idea of putting it on. You can put it on your Christmas tree.
Mm-hmm.
That's what I was thinking of doing
And
at my grandparents' house.
yeah.
After
Here, let's
Christmas.
have you. Can you scoot over?
So-
So if you wanted to, before you lower the snowflake in, you can add some food coloring. I would add only 1 drop and mix it in thoroughly before putting your snowflake in. So you can make maybe blue crystals if you want. I personally like it plain. It's white, it shimmers in the light. So the crystals form and build on one another as water lets go of the excess borax and as the water evaporates. So next week we will see it. This should crystallize by tomorrow, but we're gonna leave all of ours at school and get them next week. I hope you have a great week, you guys. Remember your memory work for this week, super easy. Like dissolves like. If you want it to a song, like dissolves like dissolves like. Duh. I don't know. Easy enough, you don't need a song for it. I'll talk to you later, guys.